So my students inspired me to make more visually appealing videos. So I threw up some images on here, working on my editing skills. So how can steel be used to make these massive skyscrapers? And steel is also used to make these tiny, super precision surgical tools. Well, it's because steel is not a pure substance, it's not just one substance, it's a mixture of elements. We call that an alloy if that mixture has metallic properties. So we're learning about this because in our current chapter we're learning about the bonding that happens in metals, and because of the nature of that bonding, we're able to add elements into a host metal. In this case, steel is made up of, pick a different, there we go. Steel is made up of iron, and we can sprinkle in other elements, primarily carbon. And it doesn't even have to be a lot of it. Just adding a little bit of carbon makes a huge difference. And this is the most well-known. Let me see if I can spell steel correctly. Probably the most well-known interstitial alloy. And so alloys have properties that are superior to the properties of the individual elements that make it up. For example, if we add just a little bit of carbon, we can get, well, first of all, you don't want to make any of this stuff with iron because iron rusts and it's not even that strong. So we add carbon to it to get steel, and if you want something flexible or ductile, you can add just a little bit of carbon, and it might be good for like panels for cars or something like that. If you want something much harder, more brittle, for cutting instruments, for example, you might add more carbon to that. You have kitchen utensils, your knives, I'm sure your utensils have stainless steel, made up of stainless. You add a little bit of chromium there and you get that stainless rust resistant steel. You can add nickel to that and get an even tougher steel. So to answer this question, which is why you're clicking on this link, is the question is, why are all steels, the properties of steels, not identical? Right? So the property is determined by the composition. So first of all, the composition might not be the same depending on the property you're looking for. You know, you might want food grade steel. You might want steel to make buildings. And so depending on the desired properties, you're going to change the composition. Not only that, the composition and the proportions. So even if it is two types of steels made up of only the same composition like carbon and iron, changing the proportion of carbon in that host metal will change the properties greatly. You can also treat it differently to get different properties. So we skipped this image here. Steel is the most well-known interstitial alloy. So let me put that up here. All right, interstitial alloy. You can compare these images and you can see that's where we have a secondary substance filling in these gaps of that host metal, in this case iron. This up here is a substitutional. So this is the next answer to the next, or related to the next question, which is about brass. Spell this right. Substitution. Oops. There we go. Substitutional. And here the host metal is copper, and we're just substituting a copper metal for a copper atom for a zinc atom, and so we get brass. So there is these two problems were so similar. I just threw them up here in one video. So it's the same question. Why are the properties of that brass not identical? It's not identical because brass is an alloy. That's not the answer to the problem. It's an alloy, and therefore you can change the composition. You can't change that. You can't change the composition of pure substances, but because alloys are mixtures, you can change the composition. and the proportions. So if you want a different color brass or different property brass, you would change the amount of zinc you add to that copper. We actually made brass earlier in the year. If you recall, we took copper pennies and we coated them with zinc. I don't know if you knew it was zinc at the time, but that's what it was. We heated that up and we got something that looked like gold, but it was brass. So next time you look around, no doubt you'll see alloys, your kitchen knife, your this and that, and stop for a moment, pause, and I think, hey, we wouldn't. There's the chemistry behind this that allows us to understand how we can make the most out of alloys, and they're all around us.